is a to the power of 5 less than 4 to the power of b? Meaning, is a times a times a times a times a less than 4 times 4 times 4 times 4 b times b of those? Oh, I wonder what a and b are. It's worth noting though that since a has an odd exponent, an odd power, a to the power of 5 will be negative if a is negative, and it'll be positive if a is positive. Of course, it'll be 0 if a is 0. Whereas with 4 to the power of b, that's always going to be positive because the base is positive. I mean, if you have a positive base, does it really matter how many times you're multiplying it times itself? Like, how could you turn negative if all you have to work with is positive factors? So if we find out that a is negative, that would give us a definitive yes. That would be sufficient. If we find out that a is 0, that would also be sufficient because we know that 4 to the power of b has to be positive regardless of what the value of b is. It's only if a is positive that we'd need some more information in order to answer the question. So looking at the statements, I really want to start with statement 1 because it does imply that a is negative. If a with an odd power is negative, then a must be negative, and as we established, that gives us a definitive answer. So statement 1 is sufficient on its own, and we can go ahead and eliminate any answer choices that claim that it's not. So B, C, E all gone, we're down to just 2 answer choices, A and D. Let's evaluate statement 2 right after this. So with statement 2, we are able to infer that the value of b is either 4 or negative 4, which means that 4 to the power of b would be either 4 to the power of 4, which is 256, or 4 to the power of negative 4, which is 1 over 256. Now, to be clear, I would never actually compute these values on the GMAT. I just did it for our purposes. But it's enough for us to just say, look, we know that the right-hand side of the question stem is some positive number. It's either some small fraction or some fairly large number. But we don't know anything about the left-hand side of the inequality. So without knowing a single thing about the base of that exponent, without knowing anything about a, how could I possibly establish which side of the question stem is greater? It's just impossible. So statement 2 is not sufficient on its own, and the correct answer is A. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.